All right, we'll go ahead and get started. So welcome everybody. So we have Rachel and Jonathan, and left their experience blank here because Rachel, let's talk about yourself a little bit.
All right. I am regional sales consultant for Batesville Products. I've been doing this for about 2 years with them. Learned a lot so far and continuing to learn as I learn more projects. So excited to share what we have in store for today.
So you talked a little bit about your running. Any hobbies or things you like to get involved in?
Well, you said it, running. So I am going to do the Flying Pig Half in a few weeks. And then I've got a trip planned in July where I'll be running through some mountains for 6 days. So
awesome.
Yeah.
Great. Thanks, Rachel. Jonathan.
Yeah, thanks, Tim. I'm the regional sales consultant for the western part of the United States. I've been working with Batesville Products for just over 4 years. I've been in sales for, almost 15 years now. And excited for this webinar. I know a lot of these topics, we answer a lot of these questions all the time. So it's good to kind of get it all in one concise place. Hobbies, I enjoy golfing and riding my bike and watching my daughter play field hockey.
Great. Well, thanks, guys. So with that, let's go ahead and get this kicked off here.
Yeah, thanks, Tim. All right. The first topic we thought was pertinent was material choices. I know there's a lot of different choices and specs out there. Here at BPI, we only deal with A356. Zinc and zinc are the two different alloys we do cast here. But as always, the cost of each material plays a big role in how much each part's going to cost.
Yeah, and also the weight of the material too, because it will, for example, aluminum is much lighter than zinc, so it's going to require less labor to use it. So when you start getting into heavier zinc parts, sometimes you're going to need 2 casters to pour a zinc part compared to an aluminum part of the same size may only require 1 caster at the time.
So you had mentioned that aluminum and zinc are both casted at Batesville Products. With those specific metals, are you seeing a specific product being used one area versus the other? Is there finish constraints? Are there cost constraints? Where do you guys typically see the different types of metals from BPI being used?
Yeah, so from my customer standpoint, most of the time we're using zinc in where we need to add weight. A lot of medical cart bases. We're also seeing zinc added to where we need a high finish or a high polish, shine on the parts. And then zinc or the aluminum we're using for saving weight, obviously, with the parts. And the cost, it's a little bit cheaper to use aluminum as well.
Yeah, and it's great, like everyone knows, for electrical components too as well. And it's also food and medical grade safe. So it really depends upon the application you're looking to use them in.
The second one, designed for manufacturing. This one is great. We use this probably multiple times a week. I know I point people to our website in general, but our design guide, I think I've linked this at least 2 or 3 times this week as far as what people need to look out for when they're designing parts. What are the key factors to look at? And it's an invaluable resource, I think.
Yeah, I would agree, especially when you're getting into more complex castings and you're considering different wall thicknesses, how that will play a factor into the feed of the metal. And also just some things like sharp corners where if you're newer to casting, knowing that you need to add a radius to it. And then also understanding the parting line and the draft that's required from the parting line. And also the taller the wall is, the less draft you're going to need. The shorter the wall is, the more draft you're going to need. Just those kind of starter guides to getting the part ready to cast for permanent mold or even sand casting.
Yeah, and those are just quick checks too, right? I mean, I know the engineering team, who with a lot of the different companies know a lot of the places to start, but specifically for permanent molds, there's specs that they may not be aware of. So this is a great resource to check out and have them at least start there with knowing what they need to do and what they need to put into the product.
Yeah.
So I think you hit on a little bit, but are things like draft, wall thickness, size, volume, the specs that are listed there, are those important due to being able to physically cast a product, or are they just important because it's something that Rachel and Jonathan want?
Yeah, no, I mean, when you get into draft, obviously our minimum draft on certain parts is, 3 degrees of draft. If you don't have that draft added into, the design, you get excessive tool wear, right? And then your tool, which is already a big investment up front, might not wear as much. You might not get as many pores out of it, and your parts might not come out as, as you need them to be casted. So you might have to re-pour them. There's a lot of factors that go into, repeatability and getting the part running pretty well.
Yeah, especially with the draft, if you're not adding enough, you're going to see drag along that wall that you don't have enough draft on, and it's going to cause surface imperfections that aren't really great to the visible eye, and you'll also get your part out of spec, which is never fun to get. So it's kind of, if you can add a little bit of stock onto it, there's always ways to remove it in secondary operations like machining or polishing.
So is it important for someone with a new design to come in and expect to be fully capable to produce a permanent mold casting? Or are there other benefits of coming in with a little bit of a rougher design that you could take a look at?
Yeah, I think we see both. I see a lot of people that already know what they're doing, and there's a lot where we will get our engineering team involved to help with some of the design, or just making sure that it's a lot easier to cast. I know people utilize our team. We have a great engineering team here at BPI where they're going to help you finish your design, make sure it's castable, make sure that it's still a product that you can use. But yeah, it's been great.
Yeah, I would agree. And if you come in with a design where you are, it's not ready, but you're open to flexibility, our team can work with you as long as you can kind of call out the areas that are critical to you. We can help design the part so that it works for your end use.
Number 3, order quantity. This is always a huge question we get because different processes lend themselves to different order quantities, right? In permanent molds, we really do a good job in that moderate volume range. 1, 2 is not necessarily going to justify ordering tooling up front, and then on the high end, because we are using the gravity fed process, going to hundreds of thousands castings is not necessarily our sweet spot either. So it's kind of that moderate volume is what we're looking for.
Yeah, moderate volume and a dense casting. So if you're looking for something that needs to be low porosity, a lot of times needs to be pressure tight type of casting, it's a great process to use. And if it's heavier, the part you're going to get more for your use for permanent mold versus die casting, where they tend to do a little bit better with smaller parts.
Yeah, and that porosity thing's huge, right? I know with other processes, you're not getting that dense of a casting. So surface finish becomes a huge factor as well. And then all the secondaries kind of lead off of that. So we feel that, that moderate volume, we don't like to put a quantity on any one of them, but I think, 200-300 a year where you would start, up to maybe 10,000 castings would be our sweet spot. Most of our castings, I'd say, run in the mid thousands. It just depends on what the product is, but we're not going to get up into the high volume stuff. It's just not going to make sense for how long it would take us to manufacture those through our tilt pour process.
Yeah, I would agree.
So why does volume, so you said you don't typically want to put a quantity on it, you put a quantity on it or a range. Why does that make sense? Why do those ranges make sense?
I think it depends upon the application. So I mean, if you're looking at a heavy part, you're looking at something that's plus 50 pounds. That's something where you would have probably lower setup quantity, but you would run it more frequently just due to the weight, and also having to use more casters to help out with it, versus something that's a little bit smaller where you could have a faster time on it for production, so you could get a little bit higher quantities on it.
Yeah, and I think when you talk about your return on investment too, you're buying a tool, right? So you're using something to make the parts. And if you go into some of the lower processes where the tooling's cheaper, you end up getting more expensive parts. And then you go the opposite direction where you're putting in a ton of money into your tooling, you're getting, a much cheaper part. So it's kind of like fitting into the middle of that range. And that's kind of the thing is, hey, we're going to be at a moderate tooling cost, but our piece price is probably going to be in that moderate range as well. So once you start getting up into the high range where you're ordering 100,000 parts, you want those piece prices to be a lot lower. And on the other end, where you're into sand casting or even an investment casting, where you're ordering a lower quantity, you want the tooling to kind of offset that and also be lower as well.
So it looks like it's very specific to the process. So let's jump into this next slide here, where really you get into the specifics, because it sounds like, especially in like a job shop or a custom manufacturer, you mentioned weight, you mentioned size, you mentioned volume, you mentioned quantity, but really when it boils down to it, I think, Jonathan, you made the comment, it's ROI, what makes sense for those costs or quantities, for that specific product.
Yeah, I mean, part and complexity and size, it all factors into it. Every single project we work on is custom, right? So it's not just something off the shelf. It's everything is factored into it. You're factoring in how complex the part is. We do semi-permanent mold here as well. We can do slides, inserts, all different kinds of things to help you get as close as you can to a finished product through the casting process. But there's also a lot of other things that go into that.
Yeah, definitely. If you're looking at sand cores, cast, especially permanent mold, is a great way to use it, because one, you can cast in cavities. You can also add in with the sand core steel insert. So you're adding multiple elements into the casting, which is great. So you can create some pretty complex castings through a permanent mold.
Yeah, and those sand cores really help to alleviate machining time, right? And machining time is kind of why we're doing the casting in the first place, right? I mean, I know we're not able to cast machine every single part, but you want to get as close as you can to the finished product, and the different things we add in really help that.
Yeah.
So you guys had mentioned tooling costs, return on investment on that tool, and how it impacts quantity that drive it. So what benefit do you get out of a single cavity, multi-cavity, the different impacts that you could put into a tool, and what does that help on the permanent mold or post-processing side?
Sure. So if you're looking at multi-cavity tools, you can get anywhere from 4 to 6 parts, depending upon the size, out of that one tool. So if you're looking at volumes that are not quite die casting, but are larger in size than what's typical for a die caster, you can start getting multiple cavities in permanent mold to help, again, get that return on your investment and be able to get the quality that you're looking for in the casting. And especially in a process where if you are looking for something that's denser, less porosity, that's a great way to go.
Yeah, and I think you end up with a portion where if you are running a higher volume in permanent mold, if you do invest a little bit more in tooling and add in multi-cavities, your piece price is going to go down, right? So that's going to really help alleviate costs on per piece price versus running one small part, because setup charges and run times and cycle times all affect all the price of the casting.
Yeah.
Secondary machining. This is, a really big portion of the cost. The tolerancing, what's called out on the specs, in our design guide, there's different specs with as cast, surface finishes versus what people are looking for, tolerancing and machining. And you can add a lot. I know you had a project not too long ago where the added machining was just out of this world. So
yeah, and that's a big thing you have to consider too when you're doing machining, especially when it's a larger casting, because when you start getting into your cope and drag, in a perfect world, even then your casting will never close the exact same way. So there's a specific tolerance that you add in your casting on the machine end to accommodate that. And if you're starting to work on too tight tolerances, it could increase your spindle time anywhere. Like if you're looking at extremely tight tolerances, that could be a very expensive part to try to hold and maintain, especially since castings flex when you put them in the machining center. So they flex a lot more than if you were to machine from stock.
Yeah, and you're also paying for fixturing too, right? I know there's a tool you buy to start, but there's also tools and fixturing for machining too. So if you have multiple machining ops, sometimes there's a fixture for each operation too. So that obviously adds cost as well.
Yep.
So does the end product and where it is physically located on, like, let's say an OEM's piece of equipment, does that matter when it comes to tooling or post-processing?
Oh, for sure. If you're looking at something that is going to be in an assembly where it's going to be covered by another part, consider maybe loosening your surface tolerance. Do you need to have it have a high Class A finish if it's not going to be seen? That's something definitely to consider. And then also, if it is going to be seen, what areas of the casting won't be, so you can call out specific areas. And that way instead of trying to get the whole casting to look immaculate, you're doing the areas that are most important while still having a great functioning casting without adding that extra cost.
So function is important, and you kind of gave me a softball here for the next slide. But really the functionality, the strength of a casting, what are some processes that could be used on these castings to help make them either stronger or even denser than permanent mold provides?
Yeah, I mean, right off the bat, obviously up on the screen are heat treating and impregnation. The heat treat process really adds a couple different benefits. One, obviously the strength of the casting, and then machining, ease of machining. It really helps in, the guys working with the machining centers. It's easier to machine them when they've been heat treated. Also heat treating different products that have had semi-permanent mold sand cores. It bakes out the sand cores. It makes them easier to remove. And then from the impregnation standpoint, there's, even though the porosity in permanent mold is lower, there's certain pressure tolerancing that sometimes we need to hit that might need to be, add in impregnation to hit those numbers for PSI and stuff like that.
Yeah, because no matter what casting process you use, you're always going to have outgassing. So that's why impregnation is another great opportunity to use in a casting to make it even more pressure tight if you need it. Even though it's not up there, sometimes even looking at anodizing a part post-process, depending upon the environment the part's going to be in, is a great opportunity to use on a casting as well. Inspection. This one, that is a huge also portion that can drive cost into a part, depending upon whether you're looking to have specific certifications every time you receive your casting, to even getting lab testing done on each part can add different costs to it. FAI and PPAP tend to be a little more upfront costs when you first launch a part, and then throughout the course of the life you can do again, pressure testing. You can get liquid penetration done to the parts to see imperfections in it. Those are different types of testing and inspection you can do.
Yeah, and we're always working to get that first article sample off to the customer, but there's different requirements and different levels of PPAP that certain companies need. Certain end users need certain levels, and that does add a lot of cost. Even pressure testing, cycle times, and depending on what kind of pressure test is needed for which department, can add a lot of 10, 15 minutes depending on the test that's needed.
Yeah.
So just got a question from Chris regarding heat treating. And this is something, Chris, that we've seen kind of go both ways, but when you see it warp, he said they chose to avoid it because the castings warp in heat treat. But there are ways and processes that companies can work through to ensure that they either come back into shape or that we control the warpage while it's happening. So his question was, is it common for part to warp in heat treat process, and is it potentially not being optimized because of that? So can you guys talk a little bit about what you've maybe seen? I'd almost put it as a post-processing on the heat treat process and ways you guys have seen help solve that warpage issue.
Yeah, we with our heat treater, we built fixtures where you put the part in, you can straighten it throughout the heat treating process so it doesn't warp. Some parts will automatically not be the best for heat treat depending upon how thin they are and flat. The thinner and flatter they are, the more likely they are to torque in the heat treating process. But there are fixtures you can use to help keep the part flattened through the process.
Yeah, and most of the time ours are oriented in a heat treat basket. They kind of know how they would need to put those in there, so you reduce that. But yeah, there would be some in certain instances where it would warp if it's not put in there correctly or fixtured, like you mentioned. Surface finish.
Yeah, this is a good one. Surface finish obviously can make a casting look great, especially if it's not a hidden part. It's something that's going to be seen. So you can do anything from powder coating, anodizing. You can even get a mirror finish polish on it. I know we've got a couple of parts here that especially zinc can do really great mirror finish polish on it and chromate afterwards, because it's something that is seen by, is visible to the eye. So you want it to look great.
Yeah, I think Rachel mentioned it. What part of the, what are we working on here? What's the end use? Is this going to be hidden from sight? Does it all need to be highly polished? Does it all need to be painted? It really just matters on what's going to be customer facing and what affects that at the end.
Yeah, and there's a lot of coatings out there that can offer different aspects to what you need. If you need to do something more, like if you need a Teflon coating, or there are a lot of different coatings that you can pick from. I know we did a webinar probably a year ago, even just talking about surface finish and all the different types of coatings you can do with it.
Yeah. Packaging. This is kind of an interesting one because certain customers of ours need their product packaged differently, right? Some of them send in packaging that we use and just send it back, so it's reusable packaging. There's other customers who want each individual product wrapped individually so they can send it off to different places. And you wouldn't think about that, but just custom packaging costs dollars. And yeah,
a great way, it is a good point of customers that have returnable dunnage. So something that they send to us, we pack up their parts and in that dunnage and send it back. So they're not wasting or spending money on the packaging, and where they're using reusable crates. That's a great way to save on some money there.
Yeah, and even the protection factor when we're getting them coated or you're getting a finished product, you don't want any damage to that, right? So bubble wrapping, making sure each one is protected when it's shipping. So there's no reworking after the fact. That's something that they do a really good job of paying attention to and adding into when they're sending it out to the customer.
Yeah.
So I know packaging poses a pretty interesting guess deep dive when we're looking at quotes and how Batesville Products sends out quotes versus what a prospect or somebody in the market may be seeing on other quotes. Are there any recommendations you would give somebody when comparing quotes?
When it comes to packaging, I would definitely say if you're looking to have custom packaging, make it aware up front, because typically most places will quote based off of their standard processes internal. So if that's not something that is told up front, that could be unexpected expense at the end if you're looking to have a part packaged and ready to go to ship off to your end customer, making that known up front so that that can be included.
I agree.
Are there general things though that you should be looking for on quotes to make sure that you're comparing? So I know you broke it down specifically for packaging, but like Josh had a really good question about different coating options. When you're adding all these different processes, different coatings can be anywhere from pennies to hundreds of thousands of dollars, depending on what you're coating products in.
Yeah.
Are there general things that you guys think should be really made aware for people when they're looking at quotes and comparing costs?
Yeah, I think definitely if you have an idea already of the encoding or specific areas of the part that are critical, make sure those are called out, especially if you've got a part that is tightly toleranced and you're not really calling out what areas are important to you. Someone that's looking at it could be like, there's no way we can maintain this in our process. And so the more detail you can give on the product with aspects to where they have flexibility and design, or if there's no flexibility at all, that is a huge help. And having specs, for example, coating, if you have a spec for a coating, if you could share that always helps too.
Yeah, I think that's a huge thing, is when there's a specific call out for a certain product you have to hit. That's a big one, because when we do a lot of our coating too, it's going to be a standard powder coating. But if there's anything special or there's a special process that needs to go through, yeah, make sure that that's called out on there, because it could double, triple the price depending on what the specifics are on that spec.
Yeah.
So I think it's fair to say that really each individual product and each individual process, including all the additional secondaries, it's very custom to each individual casting that comes through. So really understanding from your provider of what you're getting and understanding, metal cost, if there are secondaries, if there is packaging or special packaging, really understanding and breaking down. Even on the tooling side of things, Jonathan, as you had mentioned earlier, you talked through that there could be machining fixtures. As you and Rachel talked through the heat treating, there could be different heat treating fixtures that are needed for either straightening or maintaining straightness on a part. So really just breaking it down and understanding the different processes, the different secondaries that really go through there. So at this time, if there are any additional questions, we'd be happy to answer them. As well, if we didn't get to any today, we will be sending out the PowerPoint, the live recording as well, and our team will be sure to follow up. Is there so a good question just came in from Mike. Is there a part evaluation program that really helps designers check their casting design? So what would you guys recommend designers really understanding what fits in what process?
Go ahead.
There are a lot of great tools out there. There's standard aluminum permanent mold and sand casting standard guides that we actually use in-house to kind of check to see like, hey, are these kind of within process? Again, our design guide is a great resource up front. It kind of calls out some of the major points, but if you're looking for high detail, there's a lot of great engineering books that can be used to double check those as well.
Yeah, and I think that design guide, like Rachel mentioned, I mentioned it, it's one of our slides. It's a great starting point, right? So you're going to get the general specifics of what you do. And then as you walk through the process, we're more than happy to, take your drawings, take a look at them, see where you need to make changes. Our engineering team's available as well. There's certain things that we can do to guide you in the right direction to make sure you're not making a casting or designing a casting that's not castable, because we don't want that. We want to make sure it's going to be castable for us, because it's easier for us to cast because it's a good design. It just helps us through the whole process. It even helps out with machining and secondaries. It just makes the whole process flow a lot better.
How would somebody find that design guide? Could they reach out to you guys specifically?
Yeah, they can do that. Also on our website, in the resource section, it's there. There's every one of our webinars is also in that section as well. There's a bunch of different guides. There's some white papers. There's so many resources that we've done a really good job of categorizing them by each topic. They're easily searchable. We send them out all the time because people have specific questions, and it's just a great, free, easy resource. If you guys need some direction or guidance, we'll be more than happy to point you to the right section.
We also have a YouTube channel, which tons of videos on it, talking through a lot of these different points too.
Yep.
Great. Well, Jonathan and Rachel, at this time, we will close out here. As I mentioned, if you guys had questions that didn't get answered, we'll be sure to follow up. And we appreciate you joining us today, and look out for future webinars.
Great. Thank you.